Welcome to Get Your FRQ On. This question is from 2016. It is question 3, and it is not calculator active. In the question stem, we're given a graph of a function f of x, which is defined on the interval from -4 to 12. The graph is just a lot of line segments joined together. It's pretty clear on the graph where the zeros are. There's some points that are labeled on the graph specifically. And we're also given a function, g of x, which is the integral from 2 to x of f of t dt. In part A of the question, we are asked if g has a relative minimum, relative maximum, or neither at x equals 10, and to provide a justification. Whether g has a relative minimum, relative maximum, or neither at x equals 10 will depend on whether g prime of 10 equals 0 and whether g prime of x changes sign there. Given the way g of x has been defined, g prime of x is f of x, which implies that g prime of 10 is f of 10. From the graph, f of 10 is equal to 0, which implies that g prime of 10 is equal to 0. So while g prime of 10 is equal to 0, based on the graph of g prime of x equals f of x, g prime of x is less than or equal to 0 for all x on the interval from 8 to 12. So g prime of x does not change sign at x equals 10, so we conclude that g of x has neither a minimum nor a maximum at x equals 10. In part B of this question, we are asked if g has a point of inflection at x equals 4 and to provide justification. Whether g has a point of inflection at x equals 4 depends on whether g double prime of x, which is equal to f prime of x, changes sign at x equals 4. Based on the graph of g prime of x equals f of x, g double prime of x equals f prime of x is greater than 0 for all x between 2 and 4, and g double prime of x equals f prime of x is less than or equal to 0 for all x between 4 and 8. So g prime of x equals f of x is increasing for all x between 2 and 4, and g prime of x equals f of x is decreasing for all x between 4 and 8. So we can conclude that g does have a point of inflection at x equals 4. In part C of the question, we are asked to find the absolute minimum and absolute maximum values of g on the interval from -4 to 12 and to provide justification. The absolute maximum and absolute minimum values of g could occur at an endpoint of the interval, -4 or 12, or at some x value within the interval such that the derivative of g is equal to 0 and also changes sign. Based on the graph of g prime of x equals f of x, g prime of x equals f of x equals 0 and also changes sign only at the values x equals -2 and x equals +6. We can evaluate all of the necessary values by evaluating the associated definite integrals. G of -4 would be the integral from 2 to -4 of f of t dt, which is the opposite of the integral from -4 to 2 of f of t dt, which should come out to -4. G of -2 is the integral from 2 to -2 of f of t dt, which is the opposite of the integral from -2 to +2 of f of t dt, which is -8. G of 6 is the integral from 2 to 6 of f of t dt, which turns out to be +8. And g of 12 is the integral from 2 to 12 of f of t dt, which is -4. Based on these calculations, we see that the absolute minimum value of g on the interval from -4 to 12 is -8, and the absolute maximum value of g on the interval from -4 to 12 is +8. In part D of the question, we are asked to find all intervals for which g of x is less than or equal to 0 on the domain of g, which is -4 to 12. Based on the definition of g provided, g of x will be less than or equal to 0 implies that the integral from 2 to x of f of t dt is less than or equal to 0. The integral from 2 to x of f of t dt will be less than or equal to 0 when x is greater than or equal to -4 and less than or equal to 2, and also from x is greater than or equal to 10 and less than or equal to 12. If you want more AP Calculus AB free response question solutions, you can subscribe to my channel on YouTube, like each video, and you can also follow me on X at x.com/getyourfrqon.